Today's topic is Newton's laws of motion. Today we learn the Newton's first law, second law and third law of motion. Newton states the three laws of motion. The first law is law of inertia. Law of inertia means what? An object at rest will stay at rest and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. That is the law of inertia. In the second law, he stated that law of acceleration or force is equal to mass into acceleration. And in third law of interaction. For every action, there is an equal and opposite reaction. Newton's law of motion are the three laws that describes the relationship between the motion of an object and the forces acting on it. First law of motion. An object at rest will stay at rest and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. That is, Newton's first law expresses the principle of inertia. The natural behavior of a body is to move in straight line at a constant speed. This is the law of motion. What is inertia? See, inertia is the tendency of an object to resist changes in its velocity, whether in motion or motionless. That is, for example, the pumpkins shown in figure, these pumpkins will not move unless acted upon by an unbalanced force. There is no force, then the motion is zero. Let's see Newton's second law. The acceleration produced by a net force acting on an object is directly proportional to the magnitude of the net force is in the same direction as the net force and is inversely proportional to the mass of the object. The momentum, which depends upon the amount of matter contained in a body, the speed at which the body is moving and the direction in which it is moving, is calculated by the momentum, that is, momentum is equal to mass into velocity, where all the quantities can be changed over time. In modern form, he stated that time derivatives of the momentum is the force. That is, force is equal to dp by dt. If mass does not change with time, then the derivation acts only upon the velocity. And so, the force equals to the product of the mass and the derivative of velocity, which is acceleration. Derivative of velocity dv by dt is equal to acceleration. Therefore, the equation becomes f is equal to m into dv by dt. That is, dv by dt is acceleration. Therefore, the final equation is force is equal to mass into acceleration. In this law, when the mass is in kilograms and acceleration in meters and the unit of force is in newtons, 1 Newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter second square. Next is the third law. We all know the third law of the Newton's, that is, force for every action there is equal and opposite reaction. This is very simple and we all know that. The third law relates to the conservation of momentum. That is, in Newtonian mechanics, if two bodies have momentum of P1 and P2, then the total momentum of the pair becomes P is equal to P1 plus P2. And the rate of change of momentum is, we can write that dp by dt is equal to dp1 by dt plus dp2 by dt. From this equation, we can calculate the momentum of the pair of the two bodies. These are two forces resulting from this inertia, a force on the chair and a force on your body. These two forces are called action and reaction forces. From this example, we can study. These are the three laws of motion which describes the relationship between the motion of an object and the forces acting on it. I hope you like the video. Please like, share and subscribe my channel. Thank you.